I believe you're able to see my screen now and see me as well. Dear student, please download this materials. And this is for the exam prep session materials. All of you, please download it and raise your hand, please. This is for the data fundamental exam preparation session. And it is a 2-hour session, dear students. All students are attending this session. And the grace time is over, so we are going to start now. The folder name is DF Exam Prep Session. And dear students, first please open this exam format. We will come to this folders, session 1 and 2 later, but first you please open this notepad file, exam format. Okay, dear students, see, there'll be 40 to 60 MCQ questions, and the duration is 180 hours, 180 minutes. Okay, not hours. Okay, it is 180 minutes. And the points may vary, dear students, like, okay, and so we have to score the marks, 700 points, right? Okay, dear student. And some marks may score 1 point, and some questions may score maybe 2 points. So there is no fixed marks. There'll be 40 to 60 questions, but the weightage of marks may vary from question to question. Okay, dear students. And these are the percentage of questions like, see, dear student, core data concepts, concept questions will be from 25%. Relational database related questions will come for 20%. Non-relational will be 15 to 20% of questions, and data analytics, data scientist, okay, data manager, okay, dear student, that related questions are 25. So it's like 25%, 20%, and 15 and 25. When you just add these, like 45 and 50 and 60 and 85, so this is slight rate see difference. The next is if you just take the right, if you take the right, I mean the maximum values like 30 plus 25, so 55 plus 20, so 65 and 75, then next is 30. So okay, dear students, so you need a lot of readings, dear students, right? Okay, and we had a very good foundation in May this year, so please read all the notes, materials which I supplied. See, next is sample question. How the sample questions will look like. Sample questions. Okay, dear students, it's simple. See, read the statement. In relational databases, all the values in a column will have the same data type. Okay, dear students, same data type. For example, it's a student age. Column name is student age, right? So student age mean it is numeric or it is integer data type. So all the age must be numeric. Got it, dear student? It's common, right? It is common. Okay, dear student, I would like to take it to, see, dear student, I would like to, next, all of you, please go to session 1 and take this employee. All of you, please take this employee. It has few columns. Let's say this is salary column and it is integer data type. See, all data are numeric. we can't see different data type data. It is not like ABC. No, it is impossible. ABC can't be found here. No, because employee's salary, it is an integer. So all the data found under this column must be the same data type value. So here date mean all date. And so here string is a character. So all must be string character. Okay, dear students. So I would like to exit and I would like to, okay, dear students, see the questions once again. So the answer is yes. Same data type. Values in a column, same data type. Okay, dear students. And in some cases, you may get maybe 4 to 5 points. In some questions, you may get just 1 point. So automatically it may vary. Right, okay, dear student. Next is how is data in a relational table organized? We know that, see, in relational database or database management system, the data is organized in rows and column format. We know that, tabular form. Okay, dear students, in a table form or tabular form, right? Okay, so like rows and columns, or we can say that attributes and tuples. So each row, it is called a tuple, and each column is called an attribute. Okay, dear students. In this case here, for example, 1, 2, 3, 4, 5, 6, 7 um, attributes or column names, and how many tuples. So like you first go to the last row, it means 15th minus 1. Last row is 15th minus 1. So the minus 1 means the reduce the first row, which is holding the data, sorry, I mean the column names. Okay, dear students, the column names. So I mean it has 14 rows or 14 observations. Sorry, don't use the word observation, database, yeah. 14 tuples. 14 tuples. Okay, dear student, 14 tuples. And next is rows and column. Which is the following tools, dear students? To visualize data, dear students, is common, okay? To visualize, for data visualization, usually we prefer Power BI. Okay, dear students, yes, Power BI tools, very powerful. Business intelligence, right? Okay, not MS Skills Management Studio, means it is a DBMS. SQL Server, it is a DBMS, database management system, like Postgres, which we learned in the last 2 weeks during Python class. So SQL Server management is like a DBMS. SQL is it is a query language. It is a structured query language. So what is the expansion? Structured query language. Okay, students, structured query language. So here, the right answer is Power BI. And see which one of the following roles is not data job role. Data analyst, we know what data analyst will do, like data scientist. And next is database administrator. They will manage data. And data analyst also managing, analyzing the data. But system administrator is different. They are the one who do the installation, right? Okay, and hardware installation, installing and installing system, right? Okay, taking next is, for example, backup and in protecting the data, right? Okay, from hackers. And this is different. System administrators is a normal administrator work done, but IT, they are IT professional, no doubt. They are IT professional. But data analyst and database administrators, right? They are, see here, role is not data job. So data job is done by two people: data analyst, professional, database administrators, DBAs. We call it as DBA, database administrator. Okay, dear students. And now next is, dear students, what index, right? It's index. See, imagine this table has fortunately just 14 rows or tuples. 14 rows or tuples. Okay, dear students. See, imagine if it has 1 billion observations, sorry, 1 billion, no problem, tuples. Okay, dear students, and searching or looking for a particular tuple in this table will be really a time consuming. It may take 1 or 2 or few seconds. Yes, that's a few seconds. To minimize the searching time, okay, dear students, and so what we have to do is we have to do indexing. So indexing will speed up searching. See, and that is, dear students, see, such enable to locate rows and quickly indexing. Okay, dear students, so searching, right? So the keyword indexing is related to database, and it is mainly for to speed up searching. Normal searching will take maybe a few seconds to few minutes, and to reduce the searching time, to speed up searching, you have to just index on this column. So you can quickly search data much faster than the traditional. If any table is indexed, you can, the searching will be at minimum, it take minimal time. Not indexed, less, maybe more time. Okay, dear students, right? Okay, so indexing it to speed up. Next is characteristics. See, one of the following statement is a characteristics of relational. See, relational, dear students, look here, all data must be stored in a characteristic. No, it is wrong. Different rows, same table can contain different columns. No, a row in a table represents a single entity. It means, dear student, look here, this is a table. We know that it is a table. Okay, dear student, it is a table. And each row here, dear student, each row is called a tuple. Each row is called a tuple, or you can say instance. Instance. Okay, dear student, right? Instance. So I mean this, we can say that like this. See, tuple 1 or instance 1. Instance 1, no problem. Or you may say observations 1. Yes, another nice name. Observations 1. Observation. Okay, just see. The second row will be one more. Yes, one more you can add. Row. Okay, dear student. Yes, you may call it as row. Yes, row 1. See, all right. Okay, and this one is tuple. Like your student, tuple PLE2. Dear student, tuple 1, and here instance. That's the instance. Okay. To an observation. Observation 2, and here there's the type error. Observation, and next is row 1 and row 2. Okay, dear students, like this. The instance. So why we say use the word instance? It means, dear student, this is a table. It's a table. Whole is a table, and it has 14 instances of employee table. It means every employee is an instance. Same what does mean, dear student? Every instance has employee number, employee name, same, employee job, employee date of join, and so The instant is same column, same data type. Now look at the questions, dear student. Look here. A row in a table represents single entity. Okay, the single entity. It means, dear student, this a next is another name is beautiful name. This is entity. It one and right. Okay, entity. Entity two. Okay, dear students. So many names. When tuple, instance, row, entity, these keywords are relevant to database. Okay, dear student, relevant to database. Yes. Right. Okay, these are. But this one, dear student, this is observation, data science, or data analytics. Okay, dear students. So data science. Okay, dear student, yes. See this. So whenever you use the key, when should we use the keyword observations? Okay, dear students, during the like see, remember, yes, the questions are relevant to data analytics. So relational data means like this tuple, the keywords used in relation databases, tuple, instance, row, entity. But dear students, when you're working as a data scientist or data manager, data engineer, you'll be using the term observation for each row. For each column, you'll be using the word variable. We know that. We studied. What did you student? So variable means just a column. Yes, it's a column. Okay, students, it's a column name. Yes. Variable mean column, right? Okay, dear students. So you must have um, a good foundation, right? Okay, knowledge in this area. Which of the following is a characteristics non-relational? Non-relational, dear students, I taught you in May, non-relational, like key, right, okay, and document, JSON, okay, dear student, yes. So non-relational mean, dear students, that in non-relational database, the data is not stored in rows and columns. Simple concept. In non-relational, the data is stored is in not table form, rows and column based form. It has, okay, dear students, see here, in non-relational, either schema free or relaxed schema, light, okay, dear students, see, in non-relational database, contain tables, no, required to use data normalization technique, no, okay, dear students, this is the right one. In non-relational, either schema free, okay, dear student, no, when no fixed structure like this, see, schema means like this. All of you, please open it. Schema mean like this. See, owner ID must be character, length is pi, no such things. So in non-relational, no schema like this. Okay, dear student, no schema like it's a schema-free database, schema-free database, or another key term, beautiful name is a relaxed schema. It means there is a schema, but not very strict. Okay, dear students. So relational, in relational, the primary key is important, and next is data type is important, and next is data size is important. Null or not null, everything is very strict. In relational, in non-relational, relaxed or free mean schema free. Schema free means no defined structure like this. This is very strict to structure. Okay, dear student, right? See the questions, right? You see these questions will go like this, dear students, right? Okay, this is why this is how the questions look like this. Okay, dear student, this is schema. Yes, we will. Okay, and excellent. Our attendance is great, dear students. Okay. Shall we continue, dear student? Able to understand? Could you please type in? Please type in, dear student, whether you are able to understand. Please. Is the pace okay? Or you feel that I'm going fast? Please type in your feedback, please. Is the pace okay? You want me to go slowly? Whether you are able to understand, please comment in one word or few words. Our attendance is great. 20 students are attending the class. Everyone, please comment, dear students. All of you, please comment. Whether you are able to understand, please comment. Is the pace okay? All of you may lower your hand, dear students. Please, everyone, please lower your hand. And please type in whether you are able to understand. It is like refreshing. We are just refreshing what we learned in the past in May, yeah? Yes, during data fundamental class. So all of you, please type in whether you are able to understand. Is the pace okay? Please type in. All of you, please type in, dear students. Your feedback is Saina, you may lower your hand, and Arina, Safria, you may lower your hand, and Mohammed, yes, you may lower your hand. All of you, please type in your feedback, whether the pace is okay, whether you're able to understand. It is a refreshing session, please. You want me to maintain this pace? Yes, thank you, dear students. Yes, now I'm seeing your feedback. Thank you. The pace is okay and the pace is good, sir. Good. Please remain okay. The pace, thank you. Able to understand. Thank you, dear students. All of you, thank you. So, dear students, see, it is a fundamental class, dear student, right? Okay, and so that's why I'm just refreshing it. Okay, so next is so now, dear students, we are going to move. We are going to this session one. Okay, session one. See, yellow session one. What we learned in the past in class one, dear student. Yes, session one in the past. See, right? Okay, dear students, we're going to refresh. Yes, we're going to review. Right. Okay. Once again, we learned in the past what is data. Okay, dear students, what is data, and what is information, and what is database, and what is database management systems. Right? Systems, not system. Okay, this system plural. Yeah. And we also learned how to list um, any 4 DBMS. Okay. And we also studied the structure of a database table or database schema, nothing but database schema, data dictionary, metadata. So beautiful names, but and which the 4 names like database schema, data dictionary, metadata, structure of data. So 4 different names, but one point, which is structure of database table. And we also learned what is row, column, PK, even non-PK attribute. And right, okay, dear students. See, dear students, look here. Please open this one, Excel sheet. This is the best example of database schema or data dictionary or structure of a database table or metadata. So metadata means data about data. Metadata means data about data. We mean, dear students, see, the whole is telling us data about owner table. So owner table is going to keep data about owners, and these are the structure of the table owner underscore T. Collectively, we call it as metadata. We call it as metadata. Structure of a data. Okay, it is database table. And see, in this table, owner ID is a PK, primary key. All the remaining column attributes are non-PK, non-primary key. Okay, student, non. So this is a primary key, right? A primary key column. Every table must have only one primary key. So in this table, owner ID is a PK of this table. In this table, for example, property ID is a PK of this table, while sales office ID, SO ID is a PK of this table. And next is in employee table, employee ID is a PK of this table. Okay, students, see, look here, data type char. When we have to use char, if the length is fixed, like IC number, everyone has IC number, but when you count it, when you count the length of IC, everyone has fixed length. At our APU, every student has unique student ID number. We call it as TP number. But every student has 8 digits TP number. So like TP0 and another 5 more digits. So in total, the length of every student ID is 8 digits. Got it? So, and so passport number, IC number, product ID, we have to use char. The length is fixed, but we use char. The length is short and fixed. The length is short and fixed. And here, first employee first name, employee last name, we are using varchar. And the maximum length is 50. Minimum can be even one can be one. See, not null. Not null mean at least one letter. Okay, dear students. So if we just put null here, the meaning is, dear student, that if we just place null here, meaning is the employee name can be blank as well. Null, because meaning is employee name may be null, but maximum 50 characters long. Meaning, so here not null mean, dear student, not null mean employee name cannot be blank, at least one letter long, at least one character long, at least, but maximum 50 characters long. Okay, dear students, right? And next is numeric. See here, basic salary numeric. 8,3 means the total length is 8 up to decimal point is 3. Here in this case, look here, bonus 8,2. Total length is like, see, 8 digits, but after decimal point 2 digits. Okay, dear students. So next is gender char 1. So we fixed M for male and F for female. Got it, dear students? So right, okay. So we know what is tuple. Each row in a database table is called a tuple. And each column, okay, dear student, each column, see here, for example, EMP ID, first name, last name, gender. So these are all column names, or these are all attribute names. Column name or attributes name. Okay, dear students, attribute name. But this one, the highlight one, is it is also an attribute, but it's a special attribute. It is a PK attribute. It's a primary key attribute. Okay, primary key attribute. Okay, dear students, it means all others are non-PK attribute, non-PK attributes. Okay, dear students, non other than primary key. So non-primary key attributes, the meaning is okay. And next is, see, the database structure or database schema look like this. Yes, like this exactly. Here it is in Excel sheet. The schema, it is in Excel sheet, right, in a very beautiful format. But it is also database schema. Yes, it is also data dictionary or metadata or structure of table. But it is not looking so beautiful. The reason is here the same is in a very beautiful format. Okay, we designed it. But here, dear students, we just write in a simple way. It's also table name, and this is called a structure of this table. So what is data? Answer is here, a collection of raw facts. It means unprocessed information. So don't answer like, sometimes to confuse you, the answer may be like a collection of raw materials. It's wrong. Raw facts. So just some values, some figures. Okay, dear students. Like, see, just imagine, dear students, just remove this. Yeah, it is the best example. It is listing for means names. All right, okay, dear students, we have a small piece of data. All right, okay, and that is a name, human name, and there is a number 19, and there is an alphabet, and there is an alphabet with plus symbol, special characters. Next is again is a human name, and again it is a numeric, there is a number. So dear student, we do not know that whether the name is a lecturer name, student name, buyer name, newborn baby name, we do not know. And 19, it is just a number, numeric number, we do not know what does it mean. F, it's just an alphabet. A plus, it is an alphabet with a special symbol. So we do not know, dear students. So it means data has less meaning. You can represent the C. You can, for example, transform this data in a beautiful format like this. Now we know that, okay, Choime is student. David is a student. Usman is a student. Dasan is a student. And FM refers to gender. A plus refers to grade. So dear student, this is best example of data. Data looks like this, raw fact. We do not know what they are. Okay, dear student, what data they are. But here, now we have processed, see dear student, it is called information. It is the best example of information. So your invoice is information. A report is information. And a grade sheet is information. Your cert is information. Any bill, invoice, it is an information. Reason, it has data which won't confuse you. But here, dear student, this is a data may confuse, but this is information mean processed. What is meant by information? Processed data. Processed data. It means, dear student, in real time, data entry operator keying data like this to computer in order to produce this report, in order to print like this. So we have to key in like this. So data may not be looking nice. And next is we print in this format. So it means we process the data to transform the data into meaningful information. See what is meant by information? Processed data. becomes information. Information has meaning. See, this, it doesn't confuse us, but here it confuses really, right? Okay, and information, best example of information is grade sheet, student attendance sheet, invoice, balance sheet, anything, dear students, in a printed form, right? Maybe a chart, a visual chart, a pie chart, a bar chart, X's XY map. It is the best example of information, because we process the data, we transform the data in a visual form, right? Okay. Let's say we key data and we see the data in pie chart. So the pie chart is an information. We process the data in order to visualize the data in a beautiful pie chart form, or Excel's, right? Okay, or example XY graph. Okay, dear students, right? Next is database. Okay, dear student, next is database. We know collection of database tables. Okay, dear student, collection of database tables. See, one, for example, one table can't be called as a database. No. If there are only one table, okay, dear students, and we can say it's not a database. A database means a collection of database tables, a collection of database tables. It means two and above tables, a collection of database tables, and a collection of data about a collection of data. There is typo error. Yes, I just noted. About any object, any object. See, best example of dear students. Now we go to here. All of you, please go to dear students, session 1. Now we are going to connect it to that. See, dear student, look here. This alone, customer cannot be called as database, but see, it is a database because it has two tables: customer table, product table. Got it, dear student? Customer and product table. Best example, yes, customer and product table. Right. Okay, at least two tables are there. Got it, dear students? Right. Okay, two tables are there. So this is the best example of a database. Reason, it has two tables at least. So a collection of database tables. See the grammar, dear students, plural. Right. Okay, and student, course, right? Okay, and for example, or objects. Library is a database. Every library has database. Reasons, the library database may have member table, book table, publisher table, borrow table, loan table, so many tables. Lazada has own database, product table, customer table, and sales table, bank tables, transaction table, order table, delivery table, so many tables. So we call it as Lazada DB database, right? Okay, Lazada database. And so next is database management system. What does it mean, dear student? A complex software. Database means a complex software. It is not like a Facebook. It is not like Lazada. No, 100 times complex than anyone can create. For example, any e-commerce, you can create an e-commerce within a 1 year time. I can, but you and me cannot create a DBMS. Even Mr. Dawson cannot create a new DBMS. I must work maybe another 10 years. Okay, dear students. So such complex system DBMS is. Okay, dear student. Anyone can create Twitter-like app or Facebook-like web-based system, or example, Instagram. Everyone can do it, possible. But which is very really time-consuming and complex? Creation of database management system. Creation of database management system. It is a complex system which manages data stored on databases. Right, okay, see, like dear students, we have data, yes, we have data like this. Managing means insertion of new customer to this table, deletion of existing customer from this customer table, or updation of first name of Joe's, or updation of email address of Joe's, or deletion of, for example, Joe from this table. So dear student, what is meant by management? Management means, dear students, look here, it's very simple. Manage means addition, deletion, updation, and retrieval, nothing but searching. So removal of data, removal of tuple, removal of rows, insertion of new tuple, or insertion of new row, and addition, editing existing data or updating existing data. All right, okay, dear students, or searching of data, retrieval of data. Right, okay, everything comes under one umbrella keyword, which is called manage. That's why, dear students, DBMS, it is a complex system software which manages databases, which manages, see, data stored on databases. We learned during the last, yes, 3 months time, dear students, one best DBMS, which is Postgres SQL. Short name is Postgres, but full name is Postgres SQL. Right, okay, we learned, okay, dear students, it's a DBMS, database management system. Right, okay, and we also learned how to add data, insert data, and next is how to delete, right, okay, dear students, and so how to update, right, okay, and how to retrieve data using Python in the past 2 weeks classes. And see, DBMS, relational database, okay, dear students, we categorize database into two families, okay, dear students, there's two categories. So there are two types of DBMS. One is relational, another is non-relational. Relational, non-relational. And the short name of relational database management system is called RDBMS. RDBMS, Relational Database Management System. Non-relational database management system is called NRDBMS or NoSQL, simply NoSQL. Okay, students. So relational database is purely based on SQL based and rows and column based. Yes, rows and column based. While non-relational is NoSQL based or, dear student, not non-table based. In non-relational database management system, right, okay, dear students, the data are stored in not in table form. Okay, dear students, and see other relational database management systems. Some database management systems are MS SQL. Okay, students, MS SQL, MySQL, Oracle, SQLite, Informix, Sybase, Ingress, DB2, MS Access. Okay, dear students, and see, this is also database schema or database structure or metadata. It is also best example. See, it is also called as metadata It is also called as metadata. So here the metadata or data dictionary is in Excel sheet form, but this is a screenshot of real metadata of any is right. Okay, it's real is a real screenshot. Okay, this is real. Yes. So now I'm closing it. Okay, dear students, I'm closing it. So dear students, could you please comment, all of you dear students, whether able to understand? It is a refreshing, right? Okay, session. Able to understand? Please comment. We are recollecting what we learned in the past. All of you, please comment at least one word or few words. Whether the pace okay, able to understand. All of you, please comment at least one word. Yes, that will help me to serve you better. Everyone, please comment at least one word or few words, dear students, please. All of you, dear students, please comment. Those who have not commented, please. Okay, next is, dear students, now we are going to move on to see structured data. It has fixed schema. Structured data, dear student, it has fixed schema like this. Fixed schema like this, or fixed schema like this. I would like to show you. Yes, go to LO1. Yes, see the dear students is like this. Fixed schema. Student ID mean must be char, must be character of 8 digits. Like example, postcode must be varchar and maximum length is 10. So we are defining the boundary and the data type. But dear students, here because structured fixed schema, see everything is fixed. Relation means skip. But semi-structured, dear students, see semi-structured mean like this, like again no character, no vacha, nothing. Semi-structured, right? Okay, it has some structure. Yes, some called relaxed. The nice keyword is relaxed structure. Okay, dear students. So don't say some structure because it's right. Some authors use the word some. Relaxed. The nice keyword is they have a relaxed structure. Okay, dear students. Yes. And see one common. This is the best example of JSON, right? Okay, and JavaScript object notation. Like first name, see here the data is in table form, but the same data is stored in JSON format. How the same data will be stored like this. See here, first name Joe, last name Jonas, next address. Okay, students, like the address one main street, go like this. The next is email, dear students, and next is contact and type, right? Okay, go to next. See, it's the next instance. It means it is just imagine from here to from here one instance. Got it? One instance. Just how many lines? One instance. It means, dear student, here we are writing in a simple way, just only one row. Got it, one row. But here the same data is stored in JSON format like this. Got it? Next is the second instance of customer. Second instance for the same, like Samir, Nadoi, right? Okay. And how it is written? See, Samir, right? Okay, like this. This is, dear student, is like JSON format. Unstructured, totally not like this. Like, for example, image form 1 and 0, binary forms, right? Okay. Just imagine police department, crime department, they store the data in image format, audio format, video format, right? Video, audio format, digital format. No shape, no structure, no, dear students, right? Okay, unstructured, right? Okay, and documents, Instagram, Twitter, emails, Facebook, whatever you post, whatever you chat with, right? Chat messages, all come under the audio, video, binary, right? Okay, right? Okay, just imagine the people who are working in crime department, crime officers, police department. They are very good in handling unstructured data. Investigation department, they are very good at. Okay, that's why they see the judgment, right? Okay, right. Okay, so the judges or the police department, they have to go through a lot of unstructured data. They have to go through before they make, for example, the final judgment. Okay, dear students. So might have structure like, see here, unstructured. See, your email, your document, all in unstructured. Okay, so data can be stored, dear students, in two ways. In the past, data was stored in file format, like a simple example. See, 1960s, right? Okay, data was stored like this. See, the same data, dear student. This, see here, I would like to show you. Yes, this is, dear student, not this, dear student. I would like to show you best example. Go to employee. Yes, all of you, please open employee table. Nice. Here the data looking nice. The same data, dear student, can be stored in this format as well, like this employee file. 1960s, the same data was stored like this, dear students. Imagine how, right? Okay, pity the people lived in 1960s. Got it, dear students, right? The data was stored in this format, complex, right? Okay, and no security. Reading is time consuming. Updation is rarely possible. Consuming, complex. Deletion is everything is complex. Okay, dear students. So, and redundancy, duplication, right? Okay. Example, university in 1960, university in 1960. Every department must maintain a department file. They have their own department file. They have their own student file, because not sharing, no database. 1960s. Imagine nowadays we keep the data on database and shareable. The moment you edit, for example, the salary of Smith, everyone, right? Okay, every authorized people can instantly access the latest salary. The moment you post anything or update your profile on Facebook, the whole your friends team can see the latest updates. Why, dear student? Repository, centralized, and data is stored at only one place. Only one place. Okay, dear students, and see now next is, so file based data can be stored like this, dear student, in files, right? Okay, or data can be stored in databases. It's the latest, yes. The latest trend is storing data on databases. So nowadays we don't keep the data in files, right? Okay, and we keep it. What we do, we transfer the data from so it means we import the data from database to CSV files, and we process it and say goodbye to it. But we don't keep the data in Excel sheet permanently. No, we keep the data in Excel sheet, not Excel, sorry, database. And whenever we need it, we just import. We just transfer to CSV file, Excel file. But we don't keep the data permanently inside Excel sheet or inside a CSV file. But we keep the data in database. The database may be Oracle database, SQLite, or Postgres. It is different. Okay, dear students, see like this. File can be stored in CSV file, comma separated, like this. First name, last name, email. So like this. See here, first name, last name. Joe, Jonas, Samir, Nadoi. Write it nice. Okay, dear students, we store the data in this format. We also store the data in XML. Most of the mobile application, okay, dear students, and sometimes you're writing a small app, very small app, calculator, just a small app, doing simple budget calculation. You don't need Postgres, no need. You can keep the data in Excel, in XML. You can keep the data in XML file. Okay, dear students, see, is a human readable data format. So XML means it does nothing but like this. See here, you're keeping the data in XML file, but you have to write a program to manipulate the data. It means to read the data, you must write program in Python, in R, in SAS, maybe other language. You have to write it. So XML does nothing. It just carrying the data. It just keep the data. Okay, it just keeps the data or hold the data or carry the data. It does nothing, right? Okay, but we have to write program to read the data stored in XML format. Read it, deletion is possible, updation is possible. You can update, for example, Node name. You can change, for example, salary. Everything is possible. Updation, deletion, everything is possible through programs. You write programs to manipulate or manage XML file. Binary large object. Okay, the students see. Sometimes we store the data in a blob, like audio, video files. Okay, the human see binary format. Most of the audio, video, right? Okay, dear students, files, digital, all stored in a blob. Binary large object. Large object. See, for example, dear students, see someone, let's say, stole a thief and enter into a home and stole some data and just ran away. And we come to know that, yes, he used a particular car. So by collecting the CCTV camera installed on the roadside, right, okay, dear students, we can easily trace. We just need the CCTV file footage, which are in blob 101010. It is possible. Image processing. See here now. Let's say, for example, you're suspecting. You have a millions of fingerprint, and whenever you suspect that particular person may be the victim, right? Okay, and he might have committed the mistake or error or committed crime. You can examine that person's fingerprint with the fingerprint database. It means you have millions of fingerprints of all citizens. You can easily right, okay, I mean cross check and find. It's possible. data are in binary format. Is possible. Nowadays, everything is possible, dear students. Right, okay. And next is relational, yes. Non-relational. See. So in non-relational, we call it as NoSQL. Non-relational, we call it as NoSQL. That how data are stored inside, okay, just inside, based on key values, based on key values. In non-relational, dear student, database, the data is stored using key value, like key value. See here, like this. So, for example, Lazada, they may have millions of products, but each product is given unique ID, where they keep all the data, because they don't, if they don't want to store in table form, they have to keep the details of each product in this way, like so many things, like one product number one and all, including the price, including the suppliers, is like endless. It's like having breakfast, lunch, dinner all together, right? Okay. And document databases like JSON. See here the same data, like key one, it's for Jonas. How data stored? Like, remember, dear students, Python, right? How data stored, dictionary format. Two, like this, JSON format. Key value, based on the key, just this is the unique key. For next is column family database, column and family database. Next, this one is like, see, 1000. And next is product. See, we store all in just in a very ugly format, like column family. Looks like table form, but different. And next is graph format. Okay, dear students, right? Okay, and next is transaction. That's we learned in the last class as well. After deletion, after creation of table, deletion of rows, deletion of tables, updation of data, we must commit. Okay, dear students. So it means each transaction, each, for example, a task that you carried out on DBMS, it's called transaction. Reading is a transaction. You're reading is a transaction. You're searching is a transaction. You're updating a data, it's a transaction. You're deleting particular student's profile, it's a transaction. You're creating something, it's a transaction. So a set of read and write operations. See, dear student, what is meant by transaction? Reading and writing. So a transaction means, dear student, yes, see here, a task, right? Okay, a small piece of work. So a transaction is called a small discrete unit of work. A small piece of work. You're reading a data, it is a transaction. You're writing something, it's a transaction. You're deleting something, it's a transaction. So reading operation on DBMS is a transaction. And writing something on a table is a transaction. Okay, dear students. And see the transaction, now we can call it as like OLTP, and next is OLAP. See, dear student, OLTP. Best example of OLTP. See, online transaction. Whenever you withdraw money from your bank account, instantly your closing balance is updated. Your profile is updated. Bank knows that you did withdrawal of X amount today from this ATM machine at this time on this date. Okay, dear students. And how many times you tried? Sometime you might have forgotten your past PIN number. Everything is recorded instantly, dear students, instantly. And after withdrawal of amount, after, for example, transfer of money from your account to another, and you log into your bank account through website, you can see that the account is updated. OLTP, instant. Okay, instant updation, instant processing comes under OLTP, instant, immediate updation. OLAP means different. Yes, OLAP is different. OLAP, see, analytical. Serious student, OLAP is analytical. See here, OL, right? Okay, and so here, OLAP, OLAP. So, for example, our university would like to know how many students may join at our university during the month December 2024. It's possible. We can predict. We can predict if you have past historical data. Okay, dear student, if you have past historical data, so it means we have to throw the questions to our warehouse. Warehouse has past data. We can we can analyze the data. See, we can analyze the data and we can predict. Prediction is possible. See, it loaded. See, OLAP. OLAP mean not instant. So warehouse keep the past data, old data, past data. And in OLAP, no immediate processing. No. Okay, dear students. So here, but OLTP, instant, immediate processing. The decisions made immediately, instantly. Nowadays, your the moment you apply for a house loan, maybe car loan, you can immediately or instantly know whether your loan application been approved or not. Instantly is possible. Reason, dear students, your bank system knows your past data, right? Okay, dear students, and your, for example, repayment capacity, right? Okay, and your means your monthly salary, everything is merged, right? Okay, dear students, so they can make decisions immediately. OLTP, right? Okay, and at the same time, bank may predict, right? Okay, okay, what type of loan you may need next year, right? Okay, and so that is possible by OLAP. Based on the past data and your loan history, they may predict. They may come to know that yes, this many customers may come to us for a car loan, for a house loan. That comes under OLAP. But here, dear student, OLTP is instant, right? Okay. And next is every transaction, dear student, every transaction on OLTP must enforce the following asset characteristics. Assets, see characteristics: atomicity, consistency, isolation, durability. So what is meant by assets or characteristics of transaction? So every transaction, dear student, must obey or must enforce the 4 transaction characteristics. Atomicity. Dear students, OLTP systems treat every transaction as single unit. Single unit means, dear student, right? Okay, and it does either it succeeds or fails completely. You, for example, you just entered a PIN number and the PIN number you entered successfully, and system is about to give you cash, but there is a power cut. So don't worry, no need, because it knows that. See, dear student, it succeeds completely or fails completely. If anything goes wrong during the time of transaction, dear student, it knows. It means it does it fully or it fails completely. It knows that you didn't get the cash. So it will roll back the transaction. It roll back. It undo the work. It undo the work. Like what does it mean? Do it, do it fully or don't do it. Do it fully or don't do it. It means do it fully, don't do it. Okay, dear students, don't do incomplete work. That is automaticity. Like consistency, dear students. See, consistency. And look here, it knows transaction. For example, dear student, the last closing balance was 10,000 ringgit 23 cents. 10,000 ringgit 23 cents. You just withdraw 1,000 ringgit. So the closing balance must be 9,000 ringgit 0.23. If bank shows that 9,000 ringgit 0.22, something wrong. Got it, dear student? Imagine nobody noticed the receipt. Please, dear students, after each transaction, you collect the receipt and don't leave the receipt in the ATM machine. Sometimes you just throw to dustbin nearby. Don't do it. Okay, you check whether the closing balance is correct, or take home the receipt and cross check. If 1 cent difference means you are cheated, it happened yesterday in the past, right? 25 years ago, yes. It is not bank issues, the programmers issues. They smartly cheated bank and the customers. Right, okay, dear students, it happened. It means they transferred money 1 cent, 2 cents from your account to their personal account in those days, 25 years ago. Right, okay, it happened. Okay, dear students, it's a smart way of stealing money. They just take 1 cent, nobody noticed that. Right, okay, and so they got it right, okay. So be careful, dear students, yeah. Isolation. See, you have a joint account with me. For example, you and me, you and I are doing joint business. You and I are doing joint business. You are in Singapore, I'm here. You are a business partner. I do not know that you are standing in front of ATM machine in Singapore, and you do not know that I'm standing in front of ATM machine at our AP University. You are about to deposit money 1,000 ringgit. I'm about to withdraw money 1,000 from joint account. Okay, so I do not know you are also about to deposit, and you do not know that I'm about to withdraw. But bank, dear student, must treat you and I, treat me like separate island. What does mean, dear student? It must handle the concurrent transaction. Concurrent. What is meant by concurrent? Not simultaneous. It means before your transaction is complete, bank software system must not allow me to withdraw. Okay, dear student. So it is the duty of banking software. It means the DBMS, the database management system, it knows that until I complete my transaction of withdrawal of money, the bank will display on ATM machine in Singapore that please wait, please wait. Why, dear student? Because another person is doing a transaction on a same account. I may be withdrawing money or depositing money. So you will see a message, please wait, please wait. Means someone is accessing, or your date means your account is being used by someone else. Means your joint account partner, which is Mr. Dasan. Like I may be seeing a message, please wait, please wait. Why? You are doing a transaction. You are withdrawing money or depositing money in Singapore. So dear student, so here concurrent access, that is called concurrent access. Who will be doing it? Who will be taking care of it? EBMS, the asset. And durability. Whenever you withdraw money, dear student, withdraw a money, your account is committed successfully. Like DBMS will write in the DBMS in the system that you have got your cash, collected your cash. Like when I deposited, my transaction must be committed. That yes, Mr. Dawson has, for example, withdrawn this much money. My transaction is complete successfully. Your transaction is complete successfully. So it must be committed, right? Okay. So that is called, dear student, right? Okay. And OLTP system, all right? Okay. Optimized, yes. And next is, see, denormalization. See, dear students, I would like to do you remember, dear students, we learned normalization. Yeah, we learned normalization. It's this one. See, all of you, please. It's a process. Normalization is a process which transforms any complex table called a normalized table into smaller table like this. See here, a table is in unnormalized, but it has some good plus side here, student. Advantage. What advantage? You can read faster. You can process faster. You can read or process faster. If everything at one place, just imagine your company has only your database, but only one table. Lucky they are. Why, dear student? They can read data faster, but they can't update data faster. Updation is trouble. Deletion is trouble. Okay, dear student, creation and insertion is trouble. They can read data faster. Excellent. They like the light speed at velocity of light. Why, dear student? Every data is at one place. Okay, so every data is at one place. So that is the plus point. No other thing, dear student. They can read data faster, right? Okay, and but so many disadvantages, right? Okay, so go back to here once again. But in some situation, dear student, yes, we must denormalize, yes, based on your company requirements. See here. See, dear student, faster. See here. I purposely highlighted it faster. So it means, dear students, don't appreciate denormalization, but in some situations, yes, we have to denormalize. What does it mean? We have to combine all the tables, multiple table together to make a worst table like this. Okay, dear student. Sorry, to make a table like this. Yes, it is not the best practice, but if company says that yes, we have to generate reports or we have to process something, right? Okay, so in this case, you collect the data from various sources and pull right in one table, big table like this, then you can quickly read it. But which is very horrible process is deletion, updation, writing. That is really possible, but time consuming, complex. So what is the plus point? The advantages of denormalizing multiple tables into one table. But here, what is my normalization, dear student? Reverse. Transforming one table into smaller multiple tables. Denormalize means we are combining multiple tables into one table like this. Just reverse. Okay. Purpose to increase reading time, to reduce reading time or to process the data faster, So it has one advantage, but so many disadvantages. See, dear student, this is a table, a normalized table, or unnormalized table, and we applied the normalization process, and finally it transformed into, dear students, it transformed into like this. See here, smaller tables like this. At the end, I will show you at the end. See, below are the normalized table. It means just one table became how many table? 4 tables, like employee project table, and next is project table, client table, employee table. Got it, dear students? So one table became smaller tables like 1, 2, 3, and 4. Okay, dear students? Yes. 5 tables. One table became 5 tables. So what is meant by denormalization? Denormalization means, dear student, merging. It means transforming all the table into one table. Just reverse. Okay, dear students, you combine all the table and make the table like this. Got it? Make the table like this. It is called denormalization. Normalization means transforming this complex table into smaller tables. So you must know the difference. Okay, dear students, what is normalization? What is denormalization? Just reverse. Okay, reverse. Normalization means one will become multiple table. Denormalization means multiple table will become one table. Okay, dear students, right. So, dear student, able to understand? Would you please comment? All of you, please comment. Able to understand, dear students? Please comment. Is the pace okay? Please comment, dear students. All of you, please comment, dear students. At least one word or few words, please comment. Thank you, dear student. Thank you. See some additional supporting, okay, dear students, like this. See here. I also made some notes here. Just yes. Remember, yes. What is member view? Is a virtual table. Okay, dear students, virtual table. Right. Okay, and virtual are derived from a table. A database table can have any number of views. Okay, this was a keyword. Yeah, just it's a keyword. Next is. Now we are going to session 2, dear student. Yes, session 2. The folder, session 2. Transaction, yes, we have just seen. Relational. See, dear students, some of the relational and hierarchy and databases. MariaDB. Okay, dear students, it's MariaDB, and see, right, who is the foundman, the development team who developed it. Okay, and MySQL people, right? Okay, dear students, MySQL people, they created this. MariaDB is a community developed and commercially supported by MySQL team. Like, okay, dear students, and popular relational, it's relational, right? Okay, and developed by MySQL team. And next is it supports multiple operating systems, and it is good for smaller databases. When it was created 2009, Postgres, remember dear students, we learned in the last class. So see, PostgreSQL, like, but we most of professionals will call it as Postgres. They just remove the OL, sorry, QL. Okay, Postgres or PostgreSQL. So Postgres is a nice name. And see, like this, yes, known as Postgres. Got it? Right? We recently used it. It's a free and it's a relational. And next is the student, and see the keyword is Berkeley. Who developed it? Berkeley. So Berkeley, they are great people, and they are the one created C language, California University. Okay, they are the one. They created the C language, the mother of all languages. Yeah, all, even not Facebook. Sorry, Java language, SAS, Python, right? Okay, and C Sharp, right? And SQLite. So many new app, complex DBMS were developed using C. That C was created by these people, University Berkeley, right? Okay, and we must salute them. The other one developed Postgres. So the product of Postgres, the product of California, Berkeley, great, right? Okay, and 1996, it supports Postgres supports. We used Postgres on Windows. MySQL, see the competition is between Postgres and MySQL, right? Always, right? Okay, and MySQL came to the market 1995. Postgres came into market 90, just 1 year junior than MySQL. See, it's also, and next is dear student, look here, right? Okay, this is it can be used even for enterprise database. Enterprise, big organization can use Postgres. MySQL is big organization can use it, no problem. Okay, dear students, no, it's no problem. And Maria, it is small. Okay, it's, see here, small. Like for example, Lazada, Alibaba, they can't use this. And next is Lazada, yes, Alibaba, they can use it, but MySQL to handle huge data. Postgres also can handle huge data. Okay, this and Cosmos DB. It is non-relational. Okay, it is not relational. So it is like JSON format. Okay, key format. This is the best example of non-relational. Non-relational. MongoDB, it is also NoSQL. It means it's non-relational. Right, okay, and see that, okay, dear students. And next is uses JSON scheme, JSON schemas, right? Okay, and cross documentation oriented, right? Okay, documentation oriented to keep the Instagram data, Twitter data, and Facebook data. MongoDB is very good to keep the data in MS Word format. In unstructured data, semi-structured data, you can keep it. Semi-structured data, you can keep it. And Cosmos, yes, semi-structured data, you can keep it. And here, Postgres, MySQL structured data, they supports structure. Maria, they support structure, rows and columns. So anything relational means rows and columns, simple concept. Anything non-SQL means semi-structured or unstructured. Okay, dear students, yes. Right. Next is roles and responsibilities. See, dear students, some of you taking the course now, yes, you may be landing on one of the job roles in the near future, I believe. Okay, dear students, like database administrator, but less job opportunities for this job. Every company needs, I mean, big company, yes, big companies need just only one DBA, but salary is in 5 digits, no doubt. Not in 4 digits, 5 digit salary, no doubt. But you must be responsible, you must be loyal to the company, because you know what's the salary of your CEO, your boss, salary, and everyone. You can access everything, and right, okay, and even you know what is your colleague's salary. Everything is possible, but you must be loyal to a company. That's very important, dear students, right? If you violate the rules, and the person who violates will be in jail. Okay, and so every company uh, may keep database administrator for a longer time, right? Okay, and a long period of time, yes. Okay, and they won't change company to company. Data engineers, okay, dear students, like you might be good in data analyst, data scientist, right? Okay, and cleansing. But dear student, data engineers are very good in documentation. They know the process. They are like a business expert, subject knowledge, data governance, and you're very good in how to name data set, how to name observations. Very good knowledge and subject knowledge. Okay, different subject knowledge, and you will when you will give data to these people, and you will supply data to analyst, right? Okay, and so dear students, see, analysts, they're very good at coding, right? They're very good. And so among these two people, dear student, who is highly paid and highly respected? Data engineers. Data analysts, like data scientists, coders, right? Okay, and but they do less coding. These people do more coding. They do more coding. I mean, not like software engineers. No, software engineers, they are coders. Data analyst, dear student, they write few lines of code, like how what we did during Python learning, Python coding time. Few lines, but we did a very beautiful job, right, dear students? Just few lines of codes in Python to make amazing job, or do amazing job. Like data analyst, they write a few lines of code in R, SAS, Python to do beautiful job. But software engineers, no, they have to sit and okay, just align, write millions of lines. All right, okay. So who developed the softwares like Lazada and Alibaba, right? Okay, dear students, software engineers, right? Okay, not data analysts, not data engineers, not data administrators. No, these are different roles. Okay, dear students, and so based, if you have a great passion for coding, you please prefer data scientist or data analyst job. And if you have great passion for documentation, writing, and next is you would like to be in managing role, yeah, managing role. Next is you would like to control over the data. You will have the control over the data, and you would like to give instruction to database administrator. You're the one. So whenever an employee joins in a company, right, dear student, and so data engineers, they will give they will get some data from HR, and data engineers will pass data to data administrator. Okay, so data engineers are highly respected, and they do the role like managing role. And next is they are very good in governance and documentation process-oriented people, right? Okay, and database administrators are techie, like they are very good in installation and installation of database and installation backup. And if data got corrupted, who is responsible? Database administrator. If you lost data, contact data administrator. And if, for example, if you like to install a software, contact database administrator. I mean, software means Oracle, MySQL, any DBMS, whether it's relational, non-relational, contact database administrator. And whenever any employee resigns and to do the changes in our system, contact a database administrator. Right, okay, dear student, that's right. See, database administrator roles. They are very good. Database administrators are very good in database designing, normalization. They are excellent. Very good, dear students. Database administrator, very good. Normalization, denormalization, they are expert in it. Okay, dear student, they are expert in it. The other one, protecting your data, company data from hackers. Right, okay, I mean data, not system from hackers. System administrator, there's a difference. Security different, but data base is protected from third party, unauthorized people, right? Okay, and so that is possible by data administrator. If data theft happens in a company, who is responsible? It is he has to take the responsibility. Why data theft happens? Database administrator and data engineers. Okay, students, data analyst, right? Okay, data analyst, right? Okay, so these things, dear student. Next is transactions. This percentage of yes. Okay. Yes, transaction also we have seen. Okay, dear student, unit of work. Yeah. So now, dear student, it's a QA time, right? Okay, and so how many of you are going to sit for the exam, dear students? All of you, could you please lower your hand and raise your hand, please? Those who are going to sit for the exam, please. And when are you going to sit for the exam? Please write the date in the meeting chart, please. Those who are going to sit for the exam, and please write the date, raise your hand, and also please write the date of exam in the meeting chart. Okay, dear students, so 6th, excellent. I'm so sorry. Okay, 1 minute. On Sunday. Okay, dear students, good. 11 students. My best wishes, dear students. Thank you so much. Like this, dear students, we will have one more session, exam preparation session for Python. Yes. And Mr. Sankar, Raveen Sankar knows the date and right. Okay, dear students. So please, dear students, those who are going to prepare for the sit for the data fundamental exam, please prepare well for the exam. Go through the main notes and all these things, dear student. Read, right? Okay, a few times. No need to memorize anything. Reading is very important. Since you have studied data fundamentals, data management, Python, you have plenty of knowledge, and you can confidently sit for the exam. Okay, dear students, yes. And those who are not ready to sit for the exam, don't worry, take your own time, and then you sit for the exam later. Okay. And next is, how was overall class today, dear students? Could you please comment? How was the overall class? Could you please comment? Please comment. How was the overall class today, dear students? In the meantime, dear student, in the future, right, okay, for example, if you'd like to learn any other programming language, right, or any course, please contact our copy training department, right, okay. Instead of learning anything outside, you please contact our copy training department, right, okay, and they will help you. Yes. All of you, please write, how was the class today? Overall, okay, dear student, how was overall class today? Yes, we have refreshed here. Thank you. Please, all of you, please comment. Thank you, Noor Fortin. Our class is excellent, and Sainis says great, so thank you. And Arinisa says good class, so thank you. Thank you. You're very good students, no doubt. Okay, because I checked your programming skill, excellent. Okay, dear student, you have great passion for coding. I'll says class is good, and M says really good catching up session. However, need to, yes, self recap for better understanding. Yes, thank you. Please, yes, you have to read. Okay, dear students, yes, read more. Yes. All of you, please comment. Everyone, please comment on how was the class today. Thank you, Mohammed. Mohammed says good session with you, sir. Thank you. Yes, it is just a refreshing session. Dear student, just email me, dear student, just email, yes, just email me. Ayin, you may email me a request. Thank you. My contact number also, dear student, yes. Thank you, dear student, and sweet dreams, and everyone may leave now. Thank you, dear student. Thank you.